Hello everyone, this is Bob Ray, and I am a member of the Power Tools team at Analog Devices. And I'd like to thank you for watching this video describing how you can use our tools to design, analyze, and validate your power solutions from anywhere. Modern electronic systems include many power supplies and loads. In fact, it's not uncommon to see board designs with tens and even hundreds of supplies that can be architected in many different ways. So as a power system designer, how do you get started with a design? The answer is to start by drawing a power tree diagram. The power tree diagram is a nice way to visualize the architecture of a power system, shown here with the main input supply on the left, the individual power elements in the middle, and the loads on the right. You can quickly see the voltages and current requirements of each load, and you can start to explore the system-level performance metrics, including total efficiency, power loss, thermal performance, board size, and system cost. To make this analysis easy, a system-level design and optimization tool is needed. Doing a paper design can be difficult and time-consuming. You need to define the supply specifications, choose a power topology, and search through websites to find the best devices. Even harder is trying to calculate the values of the resistors, inductors, capacitors, and MOSFETs, and then choose the proper components that meet the design criteria. Of course, estimating the efficiency and power loss is difficult, and designing the loop compensation, which determines the transient response, is almost impossible. The better way is to use the LT Power Tools suite to design the system. The LT Power Tools suite is an integrated set of power design tools that makes designing a power system easy. The design flow starts with LT Power Planner, which is a visual power tree block diagram generator that allows you to draw the system block diagram, compare different topologies, and quickly estimate the system performance, such as efficiency and power loss. You then move to LT Power CAD tool, which allows you to search and select the best solution for each of the blocks in the power tree. When the best part has been selected, LT Power CAD then helps you choose the best resistor, inductor, capacitor, or MOSFET, or transformers from a large internal database of vendor components. You can then run high-level efficiency, loop stability, transient response, and output impedance simulations to verify the design. LT Power CAD will then generate a design report for each block along with a layout recommendation. Finally, LT Power CAD will create a schematic that can be run in LT Spice Simulator for a final detailed performance analysis. Let's now go through an example of the tool flow. Each of the tools has been integrated into a common design environment that allows the entire workflow to be controlled from a single window. Here is the previous simple block diagram example with more detail added to the blocks. In this case, the actual voltages, currents, efficiency, power loss, and size values are included. With the values entered for each block, the system metrics for total power in, power out, power loss, efficiency, and size can be calculated. The values can be entered by the user for generic blocks, or you can choose a real part to assign to the block. Another feature of LT Power Planner is the ability to do a quick comparison between different power architectures. In this example, option A uses a 5-volt input converter to generate the 2-volt rail, where option B generates all the power rails using a 12-volt input. You can see that there is a slight difference in overall efficiency and board size. The next task is to pick the right part and design the power converter. To get a list of the appropriate parts for each block, you can click on the block symbol, which opens a window where you can enter the appropriate parameters, and then search the library of ADI power products that fit the required criteria. Once you have picked the part from the database, the block parameters will be updated. Once the block diagram is complete, it's time to move on to the first design step using LT Power CAD. If you've not created a block diagram, you can enter the part number directly, or enter the design criteria for the block and then select a part from the database, or simply click on the system diagram block to open up the design tool. Design step number 2 is to select the proper component values for the resistors, capacitors, inductors, transformers, and MOSFETs. In the upper left-hand corner, you can enter the desired parameters for the design, such as output voltage and switching frequency. LT Power CAD will give you recommended values based on your design criteria, which will be shown in the yellow boxes. You can then enter your own values in the blue boxes. You also have the ability to click on any of the symbols that will bring up a vendor-supplied list of actual components that you can choose from. The component model includes all of the important parasitic elements, such as equivalent series resistance and inductance, that must be included in the power stage simulation in order to get accurate results. Once the components have been chosen, you can explore the effect of each component on the overall efficiency and analyze where the power loss is occurring. You can then play with component values to see their effect on efficiency and try to find the optimum solution. The next step is to evaluate the loop gain and transient response of the converter. Using a linearized model of the converter, you can quickly evaluate the Bode plot for phase margin, bandwidth, and gain margin in the frequency domain, and how it affects the load transient response in the time domain. Again, you can quickly optimize the designs by trying different component values and seeing their effect on the performance. Every model in the database has been evaluated on the bench before being released to ensure the accuracy of the model. The next step is to export the design to LT-SPICE for a detailed time domain simulation of important performance metrics, such as startup behavior and load step response. All the important component parasitic values are exported with the schematic to ensure accurate simulation results. The next step is to generate the design summary report, which includes a performance summary of important parameters such as voltages, efficiency, ripple, and a detailed bill of materials and an estimated solution size. There is also a board layout guideline summary that is generated that gives you some hints as to the best component placement and gives you a link to the actual demo board design files for a detailed layout example. The tools can be downloaded for free by going to the Analog Devices website. LT Power Planner and LT PowerCAD can be found on the LT PowerCAD page that includes a link to the download, quick start guide, articles, and videos. LT SPICE can be downloaded separately by going to the LT SPICE webpage that also includes a quick start guide, articles, and videos. Thank you very much.